Okay guys, here's our lesson today on negative and zero exponents. Negative and zero exponents are pretty simple to do. They're not as hard as you might think with the negatives. Zeros are actually really easy, and negatives, just put it on the denominator. It does not make our answer negative, so they're really not as hard as you might think if I were to give you that problem to begin with. So our first problem here, we have for any non-zero number a to the 0 power equals 1. So anything to the 0 power, besides 0, any number to the 0 power always equals 1. 10 to the 0 power equals 1. 11 to the 0 power equals 1. Whatever number you want to come up with in your mind to the 0 power always equals 1. Now for any non-zero number a and any integer n, where we have a to the negative nth power, okay, if it is negative, then our answer is going to be written as a fraction. Okay, so if we have a negative exponent here, okay, so I have a to the negative n, it does not make my answer negative, it's just going to put that part into the denominator. Now 1 is my numerator, and then it makes it positive. So a to the negative nth power equals 1 over a to the positive nth power. So that's how those work, and you'll have to be able to go both ways. Okay, I'm going to go to my first example. In my first example, I have 3 to the negative 5th power. So I just want you to write that using positive exponents. So to make that positive, I have to just put that in the denominator. So I'm going to put 1 over 3 to the, now I can make it positive, 3 to the 5th power. That is how you have to do that. For b, I have m to the 0 power times n to the negative 4th. For m to the 0 power, that's 1. Anything to the 0 power is 1, doesn't matter if it's a variable, times n to the negative 4th power. Okay, that's going to be 1 times negative 4th power is n to the negative 4th. To write that as a positive exponent, that is just going to be 1 over n to the positive 4th power. So that's how you're going to do that one. So the m to the 0 is just like multiplying by 1, so that's kind of like it's out of there. And then n to the negative 4th turns into 1 over n to the positive 4th. Now for c, I have a lot of parts here. Not all of them have negative exponents. The 16 does not, so that stays in the numerator. The y does not, that stays in the numerator. However, the x to the negative 6, there's my negative exponent, that moves down to the denominator. So that's going to be 16y over x to the positive 6th power. So that's how you do that. Okay, I'm going to go on to my next example. In my next example, I want you to write without a fraction bar. Okay, so I want you to get rid of the fraction bar. So this is going to require you to use negative exponents on these examples. I look at 1 to the 16th power, and I have to turn that into an exponent first. So that's 1 over 2 to the 4th power. 1 over 2 to the 4th power, because 16 equals 2 times 2 times 2 times 2. Okay, prime factorization, guys. That's how you're going to get that. Look at your prime factorization trees to help you with that. Now I want to write that without a fraction bar. That's going to be 2 to the negative 4th power. So I'm basically going the opposite way I just did in the previous examples. For b, I have a squared over c to the 3rd. Well, a squared is already in the numerator, so I don't have to do anything with that. That doesn't need a fraction bar. The c to the 3rd power does. It's in the denominator. To move it up to the numerator, I have to turn it into c to the negative 3rd power. Now it's up in the numerator. I have no fraction bar left, so that is my answer. I just have to move the part that is on the denominator is the only part I have to move. The a squared does not change. All right, I'm going to go to my last example. In my last example, we're using our power properties, so our adding and our subtracting here. I want you to make your with positive exponents here at the end. So you got to pay attention to the directions of what you need to do for your final answer. This one I want positive exponents. So all I'm going to do with these guys, remember, if they have the same base and you're multiplying them or dividing them in b, but in this case we're multiplying, then you just have to add the exponents. So my base is going to be 5, and I add the exponents, 10 plus negative 6. Well, 10 plus negative 6, guys, is 4. So that's just going to be 5 to the 4th power. Again, you don't have to multiply it out. We're using positive exponents, so you can leave your answer as 5 to the 4th power. In my next example b, I have 8n to the negative 3rd power. So the 8, nothing's going to happen to that. That's going to stay at 8. So when I divide, guys, remember I subtract. My n's are my base, so I'm going to subtract. So it's going to be n, and then I do negative 3 minus 2. Well, that's negative 3 plus negative 2. That turns out to be negative 5. I want positive exponents, so my final answer is going to be 8. That's a positive. That doesn't have an exponent, so that stays in the numerator. And to the negative 5 then drops down the denominator to make my exponent positive. So I get 8 over n to the 5th power. And that is all for tonight, and I will see you guys